is always driven by purpose. Over the years, the group has expanded its horizons across industrial warehousing, real estate, leasing and holdings, sports and entertainment, education, LMS foundation and EV charger manufacturing. Ventures that continue to empower communities while building industries of the future. Today, that same spirit drives the group's boldest step forward in clean mobility with Sun Earth Industries. Carrying this legacy forward, Sun Earth Industries represents the group's boldest step into the future. An end-to-end sustainability solutions provider, Sun Earth is engineering India's next-generation EV charging ecosystem. With chargers designed, manufactured and assembled at its Mumbai facility, proudly made in India under Atmanirbhar Bharat. More than 2,400 chargers installed across 80 plus locations. Part of India's 26,000 plus public charging stations, MOP/BEE 2025. End-to-end ecosystem, hardware plus CPMS plus mobile apps plus solar integration. Fastest growing EV infra provider built on uptime, adaptability and affordability.
At Sunny Sangla Group, our philosophy is legacy with purpose. From real estate and industrial warehousing to education and sports, every venture has been about empowering communities while creating industries of the future. With Sun Earth, we are channeling that same conviction into clean mobility, delivering EV chargers that ensure uptime, inspire trust, and represent India's Atmanirbhar vision. We are not just enabling EV charger adoption, we are laying the foundation for India's sustainable growth story.
At Sun Earth, my focus has been to fuse technology with sustainability. With expertise in software, solar energy and carbon economics, I ensure our chargers are not just reliable but also future ready. Every unit is designed, engineered and assembled to global standards, yet proudly made in India. For us, innovation and execution go hand in hand as we build the backbone of India's e-mobility future.
At Sun Earth, sustainability drives our EV transition. Energy audits refine our processes for maximum efficiency, moving us closer to a zero-emission world. For businesses, Sun Earth is more than a charging provider. It's a growth partner. Every installation brings not just energy but opportunity. More customers, more trust, and more sustainable outcome for enterprises and communities alike. Our vision is to make charging infrastructure an enabler of business growth and a catalyst for India's transition to a cleaner economy.
Why choose Sun Earth? Why do leading businesses and EV owners choose Sun Earth? Because we deliver more than just chargers. We deliver innovation that works in India. Lightest charging gun, effortless handling for all users, OCPP compliant, open standards for universal compatibility, IP56 certified, dust and water resistant durability, smart load management, efficiency for grids and businesses, proudly made in India, designed, engineered and assembled in Mumbai, ARAI certified, Sunny Sangla Group, building legacies, empowering sustainability and driving India's electric future with Sun Earth Industries.
Thank you everyone for your attention. Next on agenda are the Bright Spark lectures. Before we start, I would like to place on record our appreciation for the sponsors of Geotech Asia 2025 on behalf of the organizing committee. The title sponsors were Sunny Sangla Group and J. Kumar. Our diamond sponsor was McAfee. Platinum sponsors was NA Construction, Monte Carlo and Afcons. The gold sponsors were Keller, Savi Infrastructures, TechFab India, Garware, SANI, PFEPL, Pavoy and Megha Engineering. Silver sponsors were ITD, Strata, Ferroconcrete Construction, PRD, SMC Sohams, and Resustainability. The organizing committee express our heartfelt gratitude to all the sponsors for making this event happen. We will commence this Bright Spark lectures in another 2-3 minutes. We are waiting for the arrival of the President of ISSFG as well as the President of IGS to commence the event. Thank you all. Good evening once again. I request the chair of the session, Engineer Ash Cooper, to kindly be on stage.
छोटा वाला एक बैटरी ये है चल दे
Wonderful. Thank you all for coming along to the final session for the conference. It's the part I personally get the most excited about because it gives you all a chance to see what the next generation of your colleagues is going to look like, and also gives us a chance to have an idea of who we might become as we get older and more advanced into our careers in geotechnical engineering. But without further ado, I won't say too much more, and you'll see the brilliant accolades of the presenters and speakers as they come up here and walk you through what they're going to talk about. So, Dr. Chadul Haq Chowdhury, I would like to invite you to the stage to present your presentation.
A very good afternoon to all of you. Myself, Saidullah Chowdhury, Assistant Professor, IIT Bhubaneswar. First of all, my sincere thanks to the ICT and Indian Geotechnical Society for the prestigious Bright Spark Lecture 2025 opportunity here at Geotech Asia Conference. I am very glad to stand before you to get this opportunity to present my work on underground pipelines subjected to different kind of loading scenarios, particularly focusing on explosive load and traffic load. Before going to my presentation, I would like to express my sincere gratitude to my co-author, Professor Deepankar Chowdhury, who was my supervisor during my PhD time. So, as we know, pipelines are nothing but a lifeline of a country, and it can be considered as a means of a particular country. And if we talk about onshore pipeline, there is an offshore pipeline. Today I will mainly discuss towards the onshore buried pipelines. And compared to buried pipelines and above ground pipelines, buried pipelines are more preferable as it can avoid the disturbance on the surface, and also it can protect due to the surrounding soil against the displacement of the pipelines in any direction. However, if we talk about the failure of pipeline, it can cause the catastrophic situation like leakage, source of the fire, contamination to the ecosystem. So proper design of the pipeline will have to understand different possible load scenarios, and from the geotechnical perspective, one of such loading conditions can be earthquake-induced permanent ground deformation that we can see from this first figure. Another can be, this is another pictorial presentation that represents the classical landslide incident that happened in China, and from ground deformation it has been observed that most of the ground deformation in horizontal directions, and we can capture the pipe deformation as a quadratic polynomial if I talk about particular this landslide incident. Another source of loading that because of that pipe can fail, that is the pipe bursting. So pipe bursting is a trenchless technique. As we know, during this operation, an expander will be attached along with the new pipeline, and new pipeline will take place the position of existing pipeline. And during this pipe bursting operation, there can be a possible source of ground deformation, ground heave will basically generate, and that can have severe impact on the surrounding underground utilities, if any. Nowadays, pipelines are very often placed below the road pavement. It can be across or along the direction of the traffic roads. So because of the traffic roads, also pipeline fail. So we have to design the pipe such a way that it can sustain the overburden pressure and also the heavy traffic load. Pipe can be also subjected to the blast load. So this is another pictorial presentation. If I talk about the blast load, it can be, as you know, it can be surface waves, underground blast wave, or it can be above ground, that is the air blast. So blast source can be in the form of terrorist attack or accidental damage or construction required blasting. This pictorial represent shows the different types of the blast and the source of the blast as well. Typically, we can design the pipeline considering the blast as an exponentially decay function analytically. So these are the pictorial presentation of what will happen if the pipeline fails below the road pavement. It may cause if we talk about here, the particular water pipeline where leakage happens without affecting the pavement. It can pass through the pavement, or it may cause the uplifting of the pavement, or in the fourth figure if we see there may be cavity generation below the pavement may occur because of the dependency of the how much failure happened. So this is one of the real field scenarios that happened in Los Angeles as reported by Barnett et al. Similarly, Lee et al. Also investigated considering the concrete pipelines. It has been found that when the heaviest axial load has been placed just above the pipe ground, it can cause the most unfavorable condition. This small video clip also shows the consequences that may happen if the pipeline, so it will not only impact the consumer of the pipeline as well as the traffic flow. Now coming to the different modes of the failure of pipelines, so there is a total 4 modes. If you talk about, first one is the shell mode buckling. So this type of the failure will happen particularly considering of large diameter pipeline, and if it is buried in the deep trench, this is the first figure, under the compressive load or the bending stress, such kind of failure may happen. Now comparatively the smaller diameter of the pipeline, if it is placed comparatively at shallow depth, then soil will try to resist the uplift movement of the pipeline, and this kind of the failure mode can be defined as a beam mode buckling. When pipe may also subjected to the tensile force, and because of that tensile fracture may happen. So we have to design such a way it should have more ductility, because more ductility will resist such kind of the failure. Again, during the loading condition, based on that, pipe cross section may change from circular to oval, so it can be defined as the such kind of ovalization failure of the may happen. Now coming to the design aspect. So basically, we can design either in the most simplified condition, that is considering the beam spring element. We can consider the pipe as a beam element and surrounding soil, as you can see, as a spring element. Spring can be all orthogonal direction along with the axial direction based on the loading scenarios. And in case of the dynamic loading, if it is there, we can also introduce the developer. Instead of the beam element, we can go with the shell element also, or also we can design as a plane stem model, because pipe, as we know, is a one directional element we can consider, or if we want to try to more realistically soil pipe interaction, we can go with the three-dimensional finite element model. Each of the modeling technique having some advantages as well as the drawback. If I talk about the first one, that is the beam spring model, although it's not that accurate model, but we can get very quick results, and it is economical, and as it will not take much time to get the response of the pipeline, we can get very quick result, but of course towards the approximation. But if we want to get the more realistic one, we can go with the detailed three-dimensional analysis. But it's a time consuming. So based on the relevance of the work, we have to decide based on the certain parameters, such as how much time it will take, how much cost it is, and how much accuracy we need. Based on that, we can go with the proper modeling aspect. So coming to my work, that is first work that is particularly focusing on underground blast route. What is the impact on that on the pipeline response? So basically, air pipe has been considered as an oil abundance beam element simplified one. That is the first modeling approach we have been taken. And soil has been represented as a viscoelastic foundation. As it is a dynamic problem, so damper has been introduced, and this surcharge load is nothing but the self-weight of the soil above the pipeline. So this is the exponential decay function to define the blast load. What will happen just after the blast? Use pressure will generate, so PS, this is the peak overpressure. And within the blast radius, after certain time, it will reduce to ambient pressure, and further it will follow a negative phase that is much lower if we compare. So in our design aspect, to get the response of the pipeline, only the positive part of the blast load has been considered. So this is basically governing differential equation for the pipe deflection and the corresponding solution. Once you get the displacements, we can derive the other parameter as well. So I am not going too much about the mathematical complexity. So further, once we get the response, so these are the some parameters has been considered for performing the parametric study. For instance, first figure, as you know, with increasing the TNT charge weight, blast response is going to change. Further, if we increase the standoff distance, that is the source between the blast and the object. That is nothing but standoff distance. If we increase peak pipe deformation, or we talk about the strain, it's going to reduce. Defined like this way, fracture rigidity, damping ratio, or other parameters also taken care during the parametric study. And in the case 2, earlier that problem that has been solved, basically there is a blast and the pipe. Now we have introduced another barrier layer as a protection layer. It can be a flexible barrier, it can be a rigid barrier. So for mathematical expression, we can nothing but we can consider it is a double beam spring system, and also damping and all those things is there. So if we see, this is the coupled governing differential equation. So first equation represents the governing differential equation for the barrier one, and second one is the corresponding to the pipe. So once we get the displacements, we can other response we can similarly produce. So this is one of the validation study, and from the second picture we can see the bottom curve representing the displacement of the pipe if there is a in between barrier layer, and mid one is the without any kind of the protection layer. So we can conclude that in between, if we provide the protection layer, pipe response is going to reduces. So next part is on the particularly focusing on the traffic load impact. So similarly here also two cases like earlier. Case has been considered. In one case there is a pavement, below the pavement there is a pipeline. So this is again the double wheel spring system, and in case 2, in between the pavement and the pipe there is another barrier system has been introduced. And to generalize the analytical formulation, each of the layer having the defined properties. So if it is an uniform, then K1, K2, K3, all other parameters can be same, or we can, based on the surrounding conditions, we can define accordingly. And again, these are the coupled differential equations for the case 2. So if you see D1, that differential equation has been corresponding to the pavement, and second is the corresponding to the barrier, and third D3, that third equation is corresponding to the pipeline. And this is one of the validation study. And this is the mean span deflection time stream. How the pipe response has been going to changes with respect to time. Then also if we introduce the barrier system, pipe is going to reduce its pipe response. So here one thing I would like to highlight is all the problems, whatever I have done, this is basically based on the two simple steps. First step is to define the governing differential equation based on the particular case. And once we get the differential equation, next step is to get the solution of that particular differential equation. And how to get the solution? It is based on the proper boundary and appropriate continuity conditions, whatever the available based on our particular problem. Similarly, this work is particularly focusing on the earthquake-induced down deformation. If you see, initially we have to consider that cosine function that has been used to replicate the specially distributed down deformation pattern. And at the center point where 0, 0 has been defined, that is the peak ground deformation, and that ground deformation has been reduced to 0 after a certain distance, that is x1, if you see, and beyond that there is no deformation. So we can divide this problem as a two zone, or in one zone there is a deformation zone and another is there is no deformation zone. So similarly, here in case of the instead of Euler Furnace beams, we thought about the Timoshenko beam. Timoshenko beam has been considered to replicate the pipe and serve as a pyramidal foundations, unlike nuclear foundation. So here these are the coupled differential equation and corresponding rotation. Rotation term will come because of the Timoshenko beam. So first one is corresponding to landslide zone or down deformation zone, and in the second differential equations are corresponding to non-deformation zone. And these are the final solution, that is the W1x and W2x. That is the pipe deflection within the deformation zone, and W2x represent the pipe deflection beyond the deformation zone. So there is the advantage. We can only simply plug in those parameters like C1, C2, C3, alpha, beta. Those are the function of known parameters like baby pipe dimension, soil parameters and all. Only simply if we, in spreadsheet, if we plug in those input parameters, we can get easily the pipe deflection. And once we get the deflection, other are the derived parameters like stresses, strain, all those things quickly we can get. So these are the advantage of this particular type of work. So from detailed parametric study also, as usual, we changing the pipe diameter, if we see pipe strain or response is going to increases, and also pipe response is going to change, changing the width of the ground deformation zone, how much, what is the peak of the ground deformation, different types of the soil condition, and also we have changed from initial cosine to other type, other shape function to replicate the ground deformation pattern, and the thickness as well. Those, although we can see that we changing those parameters, whatever the trend we are getting, these are obvious, of course these are obvious, but these also further validate in one way that our proposed from simplified solutions are in the right track. And this table particularly highlighting the critical ground displacement has been defined. Critical, this terminology I want to tell, like with increasing the initial ground deformation at small magnitude, if we consider pipe will follow with the same rate of ground deformation pattern, but after certain peak, the pipe will not follow the same rate of ground deformation. So from instant where the pipe is not following the same rate of ground deformations, that particular displacement has been defined as a critical ground displacement pattern. And similarly, we tried to replicate the real incident that happened in Zhejiang province in China in that landslide. We have found that from literature that we can use the quadratic differential polynomial function if you see the first differential equation on the right hand side to replicate the actual ground deformation pattern that happened in that landslide incident. And second one is again beyond the non-deformation zone. And similarly, based on the conditions, we can get this is the final solution W1x, W2x again in the same question. W1x is represent the pipe deformation pattern within the landslide zone that happened in Zhejiang province of China, and W2x we can get the beyond deformation zone. And at last, we try to get the response of the subjected to pipe bursting underneath. As I discussed during the pipe bursting, ground heave will generate. And what is the impact of that ground heave on the adjacent pipeline if there is? So from the literature it has been well established that such kind of ground heave due to pipe bursting or settlement due to tunneling can be well represented by a Gaussian error function. So basically Sx, that function represents the Gaussian error function. It is a function of theta, that is a generalized form. Theta represents the intersection angle between the pipe bursting. If you see left hand side figure where pipe bursting location that defines that operation is going on, and above that there is another pipeline. So in this particular figure, this is theta is 90 degree. So theta can be any intersection angle between the adjacent pipe and the pipe bursting axis. So that has been incorporated in our analytical solution, and these are the Wx as the final solution of the pipe deflection considering both the Euler-Bernoulli beam and Timoshenko beam. And now coming to so far whatever I have to discuss considering different loading scenarios, I have proposed some kind of simplified analytical solutions. But in next few slides, I will highlight some of the validation study that has been made with respect to experimental data as well as three-dimensional numerical analysis. So again coming back to the pipe bursting operation, there earlier Zaleatom 2009. They have performed a full-scale experimental study in similar fashion, like there was an unreinforced concrete pipe that has been replaced by a HDP pipe, and above that there was a PVC pipe, and then they tried to get the response of that adjacent PVC pipe in use of the pipe bursting operation underneath, and the response has been recorded in terms of pipe deformation and pipe curvature, as we can see from the right hand side those figures. And later on, same concept has been replicated by Shi et al. In the numerical analysis. Although numerical analysis also in the simplified way, like beam and pipe swell interaction spring element has been used to replicate the soil. And that concept has been validated with our proposed simplified analytical solution. You can see, as fully speaking, the experimental results give little underestimation, or in other way I can say it will be more appropriate to say that our closed form solution is give little overestimation in results. That is because of the simplified, but those variations are within the acceptable limit. Similarly, from our end, independent numerical analysis has been performed to replicate the pipe bursting, and we have recorded what will be the Grisfield ground heat profile at the location of adjacent pipe, and that has been validated with the RDN numerical analysis as well as the proposed closed form solution. And similarly, for the case of the ground deformation pattern, also the proposed solution has been validated with the past numerical analysis. And from our end also we have validated, we have performed the three-dimensional numerical analysis. Here, the block pattern ground deformation, we have shifted from the spatially distributed to abrupt, just to cross-check again whether those analytical formation will be able to give the appropriate result if we change the functions, and it has been compared with the numerical analysis as well. And for the blast tool also, it has been validated with the centrifuge and three-dimensional numerical analysis. And for the traffic tool also, with respect to the past studies as well as the numerical analysis has been performed. So from all the validations, what I can say that all the validation is perfect, but of course there is a little overestimation in results, but within the acceptable limit. So those kind of the analytical solution, as we are getting very quickly, within a fraction of a second we can get, because if we plug in those final expression in the spreadsheet, we provide the only thing is we have to provide those input parameters, we can get the pipe response. It will not be that much time consuming as we have to do the case specific numerical analysis. So we have some drawbacks, we have some advantage. So coming to the key takeaways, like proposed generalized closed form solutions to evaluate the pipeline response under traffic and explosive flow. those mathematical models are also extended for the case of the pipe subjected to other loading scenarios such as the earthquake-induced ground deformation. And most importantly, I would like to highlight third point. These models offer practical tools for engineers to estimate the pipeline response efficiently, especially in preliminary design stage without relying on resource-intensive detailed numerical simulation. So by capturing the critical aspect of pipe-shell interaction and deformation mechanism, the proposed formulation contributes towards safe and resilient pipe infrastructure. So at present, I am extending this research towards the green energy sector, particularly focusing on the district heating and cooling system and geothermal, because in those cases, pipelines also play a very vital role. As you know, what will happen because of the temperature variation or seasonal variation or because of HPHT pipeline sudden shutdown, the pipe is subjected to huge number of cycles in terms of more than 1,000. So pipe will be subjected to number of axial load. Then what will be the exact axial soil resistance that has not been yet taken care? Even if we talk about the international guidelines, American Lifeline Alliance or FC guidelines, whatever the closed form solution has been given for the to estimate the axial soil resistance is not capable to replicate those kind of case specific like DSC or geothermal energy where temperature will vary. So my intention is experimentally to understand the pipe soil interface behavior and the actual soil stress distribution because of number of axial cycling load, and finally to propose a closed form solution so that it can be helpful to estimate the actual soil resistance. Thank you so much for your kind attention.
Thank you very much, that was wonderful. We will see if there's time at the end of the next talk, and then we can invite both the speakers up and take some questions from the audience.
Thank you.
One more, please, everyone, round of applause, thank you. I'd like to invite our second Bright Spark lecturer up to the stage, Suwan Hitotuyani, who is joining us, he's coming from Australia as well, fantastic. University of Technology, Sydney. Please welcome him to the stage.
Good evening to all of you. I'm a PhD candidate at the Transport Research Center of University of Technology, Sydney. And today for the Bright Spark lecture, I will present a part of my PhD research. And the presentation is titled Utilization of Rubber Grids Made from Waste Conveyor Belts for Enhanced Ballasted Track Performance. And my principal supervisor is distinguished Professor Divindra. Right, so this is the outline for my presentation today. First, I will briefly go through introduction, and then I will introduce the novel solutions that we have proposed for the track problems. Right. Moving on to introduction. So Australia has one of the largest railway systems in the world with more than 33,000 kilometers in length. And during the past few decades, the demand for railway transportation has increased significantly. And you can see from the figure sourced from the Bureau of Infrastructure and Transport Research Economics in Australia. You can see after the year of 2000, the demand for railway transportation has increased almost exponentially. The reason behind this increased demand is the increased demand for bulk goods such as coal, iron ore, bulk grains, etc. So because of this increased demand, railway companies have opted to use heavier and faster trains. So what happens when we use heavier and faster trains? Higher and higher loads are being applied to the rail track in high frequency. So of course, when higher loads are being applied to the rail track in high frequencies, several track problems occur. One of the major problems is ballast degradation, that is breakage of ballast particles. That is a very serious problem because it leads to other major issues like ballast fouling, differential track settlement, improper drainage, and lateral buckling of track. Like you can see some track issues in the figures to the right side of the screen. And these problems, these track issues need to reduce passenger safety and comfort. And in the state of New South Wales alone, in Australia, over $1 billion Australian have been spent during the period between 2016 to 2020. So what can be done to address these track problems? So the main thing we can do is include some kind of a stabilizing inclusion within the track substructure. One of such inclusions is geosynthetics, like geogrids, geocells, geotextiles, or geocomposites. The main function of these geosynthetics is they reinforce the track substructure, mainly ballast layer. And the other main track stabilization method is including resilient rubber elements within the track substructure, like under ballast mats, under sleeper pads, rail pads. The main function of these resilient rubber elements is they increase the energy dissipation capacity of the rail track. And geogrids and resilient rubber elements like under ballast mats are two of the most commonly used track stabilization methods. Even though geogrids and under ballast mats are two of the most commonly used track stabilization methods, they have the inherent disadvantages. If you look at geogrids sometimes undergo rupture under high stresses and lose the reinforcement capacity. And geogrids do not dissipate energy that well because geogrids are made from plastics, propylene, polymers like that. And geogrids do not perform well in reducing ballast breakage. That is because they do not dissipate energy that well. If you look at under ballast mats do not allow free drainage through the layer because under ballast mats are a continuous sheet of rubber. And under ballast mats do not provide adequate reinforcement to the ballast layer. Thereby, they do not reduce the lateral spreading of ballast that much. So, in order to address these problems of geogrids and under ballast mats, and to combine the particle interlocking property of geogrids and the energy dissipation property of under ballast mats, we have proposed 3-cycle rubber energy absorbing grids. These 3-cycle rubber energy absorbing grids combine the particle interlocking property of conventional polymer geogrids and the energy dissipation property of rubber under ballast mats. These rubber grids are derived from discarded conveyor belts from the mining industry, mainly in Western Australia. As you can see, these discarded rubber conveyor belts are very bulky. They take up a lot of space in landfills. So kilometers and kilometers of length in discarded conveyor belts go to landfills every year. And because we are using waste material, these rubber grids are both environmentally friendly and sustainable, and we use water jet cutting technology to cut the grid apertures into these rubber sheets. You can see the final rubber grid there. And I will show you guys a small video of how we cut the grid apertures into these rubber sheets. This water jet cutting was done at the Tech Lab of University of Technology, Sydney. Right, so to check the effectiveness of these rubber grids, I have conducted large-scale cyclic loading test program and a field test. I will present some of the results we will take from both of these programs. So move on to large-scale triaxial test program. So I will use this process simulation testing apparatus that is located in UT's Tech Lab. This testing machine has the capability of simulating real-life track conditions such as realistic track boundary conditions and realistic train loadings. And yeah, you can see the black color sample box. So what we do is we first compact the 350 millimeters upgrade layer, and on top of that 150 millimeter thick capping layer, and on top of the capping layer we compact a 300 millimeter thick ballast layer. On top of that we place the rail sleeper assembly, and the vertical dynamic actuator is used to apply the train loading to the rail sleeper assembly. So in this experiment program, I have simulated 25-ton axle load, and I have applied loading frequencies of 15 Hz, 20 Hz, and 25 Hz, which correspond to 110, 145, and 180 kilometers per hour main speed. Let's move on to some test can see, when the rubber grid was placed within the track sample, it reduced the lateral displacement significantly, up to 52% reduction in lateral spreading of ballast. That is because of the additional reinforcement that is provided by the rubber grid. And the long-term settlement increased by up to 60%, and the volumetric strain of ballast increases by up to 62%. The main observation that we have made in this experimental program is that this rubber grid significantly outperformed the conventional modular geogrids and underballast mats. In the figure to the right side of the screen, you can see the green color lines define the conventional rubber underballast mats, whereas the brown color lines represent polymer geogrids of different aperture sizes. Moving on to energy dissipation, one of the main intended functions of this rubber grid is the increased energy dissipation. By increased energy dissipation, these rubber grids reduce the amount of energy transmitted to the ballast layer, thereby reducing ballast breakage and crack formation. And it was observed that with the inclusion of the rubber grid below the ballast layer, the energy dissipation of the track increased by up to 51%. And the damping ratio of the track increased by up to 32%. And yeah, like I said, it reduces the amount of energy that is being transferred to the ballast layer. And we observed that there is slightly less energy dissipation compared to conventional rubber underballast mats, because when we use underballast mats, there is a higher volume of rubber within track sample. Right. Moving on to ballast breakage, as expected, when rubber grids were used, ballast breakage reduced significantly. Like I said before, when we prepared the sample, we used a 300 millimeter thick ballast layer. We divided the ballast layer into 3 parts of 100 millimeter thickness each. So after each test, we take out the ballast carefully and sieve it to get the new gradation and compare it with the initial gradation curve of the ballast. And we use the gradation curves to calculate the ballast breakage. So we observed that up to 21% reduction of ballast breakage in the top ballast layer, and up to 44% and 51% reduction of ballast breakage in the middle and bottom ballast layers. So as expected, the breakage increases in the loading frequency, that is the train speed, and highest percentage reduction of ballast breakage compared to the bottom ballast layer, that is because the bottom ballast layer was in touch with the rubber grid. Right. So moving on to pressure distribution with depth, we placed 4 pressure cells within the track sample, one at the sleeper ballast interface, and one at the ballast capping interface, and one at the capping substrate interface, and the last pressure cell 250 millimeters beneath the capping substrate interface. And it was observed that at the sleeper ballast interface, the vertical stress was reduced by 4.2% when the pressure cells the rubber grid was placed, and a 21% reduction of vertical stresses were observed at the ballast capping interface, and up to 13% reduction in the capping substrate interface, and up to 11% reduction of vertical stresses 250 millimeters beneath the capping substrate interface when the rubber grid was placed. And the highest reduction of stress observed at the ballast capping interface, similarly, that is because in that interface the rubber grid was placed, and minimal stress reduction was observed at the steeper ballast interface because that interface is very stiff. Right. Moving on to the field testing of this novel solution. To check the effectiveness of this rubber grid in real life track conditions, we have conducted a field testing of this rubber grid in Chulalongkorn, South Wales, that is the suburb in Western Sydney. We conducted this field test in partnership with City Trains, Transport for New South Wales, and several other industrial partners. You can see an aerial view of the field test area, which was done in the Chulalongkorn rail precinct, which is a rail yard, and you can see some schematic diagrams of the cross-section of the track, etc. Right. You can see the several stages of the track construction. In the first figure, you can see the compaction of the capping layer, the instrumentation, laying of the rubber grid, laying of the ballast, and the completed test track. And in the second figure, you can see we used settlement pegs to measure the vertical settlement, the long-term settlement, and pressure cells to measure the the vertical stresses developed within the track substructure. Moving on, load application, I will show you a short video of a trial run on the newly constructed test track. We used a 22.5-ton diesel locomotive to apply the load. This is just, the video is just a trial run. We attached 2 pole-filled wagons into this locomotive to apply a realistic weight load. And in this field test, we applied 1,000 tread passes in the preliminary stage. And this field test is still ongoing. We are still gathering data to monitor the long-term performance of this application. And I will present some results from the preliminary stage. Right. In the first figure, you can see how we measured the long-term settlement of the track. We used surveying equipment. And on the right side, you can see after 1,000 tread passes, we observed 18% reduction in vertical settlement when in the rubber grids stabilized track section. And also we used 3 pressure cells at the sleeve ballast interface and the ballast cabin interface and the cabin subgrid to measure the vertical stresses developed within the track substructure. As you can see, the vertical stresses reduced significantly in the rubber grid stabilized track. You can see up to 21% reduction of vertical stresses were observed. And you can clearly see how there was no significant change in vertical stress at the subgrid cabin interface. So this indicates that while rubber grid was effective in reducing stress in the ballast and cabin layers, it has less influence on the underlying subgrid. Right. We measured the acceleration, vertical acceleration of the test track by attaching accelerometers to the translators. So we observed that up to 74% reduction in vertical acceleration in the rubber grid reinforced test track. And it is noteworthy that the relatively low acceleration observed in field test is attributed to the low train speeds of between 15 to 20 kilometers per hour applied during testing. In fact, CC trains put for a limit of 20 kilometers per hour speed limit for the field test because the track was constructed in a rail yard for safety. And the most important feedback about this rubber grid we obtained was from the train drivers themselves. In fact, they said that when they transferred from the standard track section into the rubber grid track section, they clearly felt a difference, in fact a reduction in vibration. Moving on to the conclusions, significant deformation control, the rubber grid reduced lateral displacement by up to 55% and settlement by up to 60%, outperforming polymer geogrid side on the ballast mat. Reduced ballast degradation, overall ballast breakage decreased by up to 55% with the maximum reduction at the bottom layer, that is the ballast layer in touch with the rubber grid, and superior performance under cyclic loading. Under 25-ton axle loads, the rubber grid achieved up to 37% reduction in ballast breakage compared to around 33% reduction of ballast breakage for polymer geogrids in similar testing conditions. And enhanced damping characteristics. The rubber grid reduced stresses by up to 21% as the ballast coming interface and up to 11% within the subgrid and under heavy axle load. We conducted field tests to do field validation. The field trials confirmed 7 to 27% reduction in vertical stresses, around 18% reduction in settlement, and up to 74% reduction in vertical acceleration. And because of these observations, we can clearly say that this rubber grid is not just a research concept, it is scalable, sustainable, and it is proven to be effective both in the laboratory and in the field. Thank you.
Thank you very, very much. That was a very interesting presentation. We've got a couple of minutes, I can see on the clock. So, Dr. Chandler, I'd just like to invite you back to the stage as well, and we can just see if there's any questions at all from the audience. Can we get a microphone, please? False alarm. Does anyone else want to ask a question? Yes? Also, while Graham's thinking of this question, if anyone else would like to join us on stage, just to relax, you're more than welcome.
Graham Stoley from WXP Sydney. To our second presenter, have you thought about the long-term degradation of the conveyor mat and how you might respond to the loss of performance in the future? Because you've tested several thousand passes, but you could have hundreds of thousands of passes over the lifetime of that piece of track.
Yeah. I think so. What about
For the second presenter, please.
Yeah, regarding the number of cycles.
I'm talking to the second presenter.
Oh, sorry.
The UTS. Sorry, I know it's very difficult for you to hear on the stage. But my question was, have you considered the long-term degradation of the rubber conveyor mat and how that would impact on the performance of the track over the very long term after hundreds of passes of the train?
Yes, these mining conveyors are very durable. They are designed to carry very angular, very heavy, very large particles. So, from the manufacturer, they got that they are designed to have a design life of up to 20-25 years. But these conveyor belts are very frequently replaced, so they have a lot of the service life left in them. And yeah, they are not exposed to the environment, so no sunlight. So they are very good.
So I can ask the question. So what is the design life of the rubber mats? Because for polymer, the virgin polymer materials, we know that we can design for 100 years design life. What is the design life for the rubber mats?
The conveyor belt itself has up to like 20-25 years service life, but these rubber conveyor belts are very frequently replaced. Even if there is a slight damage, they get replaced. So when the rubber bits go to the landfills, there is a lot of service life left in them. So we can use the rubber bits made from the conveyor belts for a long time.
Question. Quick one. So you advertise for it that you are reusing the material. You're cutting from those belts. What are you doing with the small squares because the quantity is big?
At the moment, there's no use for them.
No!
I guess
it's just for backfill behind the walls.
We use 60% volume of the rubber mats, so rather than discarding 100%, we are using 60% of the waste.
Okay, good. That's it.
And Dr. Trimalfi, I was wondering, is there some key takeaways for us as geotechnical engineers on how we can make pipeline design more resilient? Is it to do with pipe materials, the depths at which they're specified to go in it, or construction quality? Do you have some comments for everyone to take on?
Yeah, regarding the plenty useful of those things. Yeah, main message is whatever the finally I have proposed different kind of the solutions for different loading conditions. So if we know the pipe different parameters and soil particular field study, we can get the soil parameters. If we know all the input parameters, so my main message is to use those equations so we can get the quick estimation of the results. But of course, it will not provide the exact accurate results. For that, we need either experimental or numerical analysis.
Mark, very last one, and then we'll wrap up.
Yes,
Yes, last one. I want to congratulate you because you brought back to me the inner feeling of how to develop flexural waves. Lateral pipes or vertical pipes, or lateral pipes or vertical pipes. So it's a great paper research. Good job.
Thank you so much.
Thank you all. To present the certificates to the two speakers, Dr. Zaidul and Mr. Suwal, I invite the President of ISSMG to come forward. I also invite the Chairperson of Geotech Asia, Dr. Anil Joseph, Dr. Ashish Juneja, and Dr. Modi to kindly come onto the stage. I request the chair of the session, Engineer Ash Cooper, to join us.
I just want to clarify, the BSL is a very prestigious award from ISSMGE established in the previous term by President Charles Navy. And it's basically encouraging the young engineers worldwide and establishing a statement that these young engineers are at the level of giving a keynote lecture. So big congratulations. Bravo. This is the most prestigious award any young engineer can get worldwide, so really congratulations. I like to give them the certificate.
Thank you. I request Dr. Mark Bellows and Dr. Anil Joseph to present a memento to the chair of the session, Engineer Ash Cooper. Thank you all. Distinguished guests, dear delegates, as the sunset approaches on this beautiful golden horizon, we have all gathered here one last time, not to end something, but to celebrate everything that has unfolded over these remarkable 4 days. We are moving on to the closing ceremony of the first ever Geotech Asia International Conference, held from 7th to 10th October here at Goa, India. Invite you all to the closing ceremony of Geotech Asia 2025. Welcome you all once again to the closing ceremony of Geotech Asia 2025. I invite onto the dais Professor Dasaka S. Murthy, the organizing chairperson of First Geotech Asia 2025, along with Professor Ashish Juneja, the organizing chairperson, Geotech Asia 2025, and Dr. Anil Joseph, the organizing chairperson of Geotech Asia 2025. A hearty welcome to Dr. Mark Balaus, the President of ISS MGE. Welcome Professor K. Jian Shu, the Vice President of Asia ISS MGE. And also a warm welcome to Dr. Walter, Vice President North America of ISS MGE. I also invite Dr. A.P. Singh, the Honorary Secretary of Indian Geotechnical Society, onto the stage. Let me now welcome Professor Dasaka S. Murthy for the welcome address.
Good evening all. So we are here witnessing the Geotech Asia, and a day before the Geotech Asia proceed, before the conference workshop and FED-IGS meeting was conducted. And all these 4 days, I'm sure you enjoyed all the technical proceedings. Not only that, I've seen a huge crowd and the welcome reception, cultural program, and yesterday's the grand gala dinner at Big Daddy. Definitely what I see here is a gathering of not only just eminent geotechnical engineers, but also a large number of students from various countries and the rest of the world. Thanks to our President, IGS, Dr. Anil Joseph, who managed to get Geotech Asia. I'm once again saying managed to get Geotech Asia to India, and thankfully we also got the ISSMG board meeting, FED-IGS board meeting, and the Asian level board meetings. With this, we've seen a large number of international delegates, and we've seen more than 500 residents attending this Geotech Asia. And I should thank all of you here because we are in the Goa city, and normally what I see, most of the delegates, they present their paper or maybe their talk and explore the Goa. Okay, and seeing here for the closing ceremony so many people, I should really thank all of you for sparing your time, not only just for technical sessions but also for the closing ceremony, which is very, very important. Just to acknowledge the hard work put behind by the entire team to make this day successful. Thank you very much once again, and before I leave it to others, I once again thank the strong pillars of support, all the sponsors and all the exhibitors, all the speakers, and most importantly, the audience. Without these people, these audience, these kind of conferences are never successful. Thank you very much once again.
Thank you, sir. And for providing a conference summary, I now invite Professor Ashish Juneja, the organizing chairman of First Geotech Asia 2025.
Thank you very much. I'll continue from where I left yesterday. I'm a bit surprised when he still didn't turn up today. Just, after all the gala dinner we had. That means you didn't drink too much yesterday. Okay, so this conference has been a very exciting journey for all of us. I mean, I would speak, I had a very in the terms of very exciting way we organized 2 board meetings, FedIGS and as well as the ISMG. ISMG will be held tomorrow. We've had 4 pre-conference workshops. There were 31 keynotes and invited speakers, 2 distinguished keynote speakers, over 26 thematic speakers. We had 258 contributory papers, 2 Bright Spark lectures, as we heard just a few minutes back, which, if I add them up, if my math is right, is over 317 papers. This is nothing short than a very large conference which is spread over 4 days. I thank you all for contributing, and really this is really a very appreciable from the organizing point of view. Speaking of organizers, this whole thing would not have been successful had the committee members of the organizers had not provided support. The support is of immense importance to the success of this conference. It was the first time this time that we started with a separate set of committee, which we call committee, or I would say coordinators, which we started to call as peer review coordinators. They were the coordinators between the review people and the passing on the papers for the reviewers and following and chasing them up. So I really thank the over 17 peer review coordinators we had to coordinate for the final 10 themes we had shortlisted. We had a bunch of over 350 reviewers for this entire exercise. This whole, again, would have not been possible without the help of student coordinators. Because we belong to the academy and we don't have the money to spend to buy we have cheap labor, but we don't have the money to buy stuff. This whole thing would not have been possible if the Anil's army of staff not have supported us. We are also thankful to the NEC members and the guidance of the steering committee. They really provided full support to the conference. There were instances when we were really getting worried about, because the finance doesn't come at one go. It comes in stages and we have to really seek support from various sponsors. So really the steering committee helped us a lot. And speaking of, again, sponsors, it would be something which I will be missing out if I don't spell them out, because they are the ones with whose contribution, with whose support and help we have been here. Our title sponsors have been Sunny Sangla Group and J. Kumar Infra. I am really very grateful to both of them, particularly when J. Kumar was one short visit and they provided the title sponsorship. This is really wonderful for them. Diamond is from Mecca-Ferry. We're really grateful to them. They had committed the amount way back when our planning had just started. I'm again very grateful to Mecca-Ferry. Our platinum sponsors have been NA Construction, which again is very supportive to us, Monte Carlo and AFCONS. Thank you very much. Our gold sponsors have been Keller, thank you. Savi Infrastructure, which kindly came in because of, again, Savi in fact is run by our own student, one of our students. That's really a remarkable thing if our student achieves great height. TechFab, thank you very much. Garve, Sunny, Pioneer. They were the gold sponsors. And Powai Infrastructure. Silver sponsors have been IDD Cementation, Strata, Ferroconcrete, PRD Rigs, SMC Sohoms, and RE Sustainability. Thank you all, thank you very much. I would also like to thank the immense support we have had from the hotel staff and the auxiliary staff. Thank you, all of you. And of course, our event managing services. We had a great time with them. And we finally are very happy that we have narrowed down to the company which stands over here. Thank you so much, very much, led by Suraj and his entire group. Thank you. We have started this year with the help of, again, a special committee under the stewardship of Mark, thank you, is to give some Best Exhibition Stalls Award. This is, I believe, thanks to a very supportive members. The committee has gone through every stall, every exhibitor, and right from various categories they form. The categories, in fact, they form was the best exhibition stall from home country, the best exhibition stall in which we had the best interactive staff being available. This is something which, again, many of the committee members really liked. There was also best innovative stall for innovation. Of course, that's the name sounds innovative. We also narrowed down to the best design and decorative stall awards. Believe us, out of 57 stalls, it was not an easy job. And thank you again very much. The home country stall, the best exhibition stall, we had to narrow down to two. Okay, the number one is hydraulic engineering and instruments, HYCO. Congratulations. Thank you. Exhibition stall again from home country is PRD Rigs, second one. The best interactive stall awards goes to Sarthi Geotech and Engineering Services Private Limited. The Best Interactive Stall Award also goes to Monte Carlo. We have the Best Innovative Stall Award, which goes to two different companies. The first one goes to McAfee. Our Hyderabad Terra Techniques Private Limited. The next category of award is Best Design and Decorative Stall Award. It goes to TechFab India and Complete Instrumentation Solutions. We have a representation from Complete Instrumentation. Thank you very much. Thank you.
Thank you all. Now I request the chief guest of this session, Dr. Mark Willows, President of ISSMG, to give your remarks about the conference. Welcome, sir.
I'm not prepared, but I will say something. Question. How many of you are snow skiers? Snow skiers. Snow skiers. So you will understand what I'm going to say. After a long day of snow skiing, or actually any long day sports activity, the best part is après-ski. You relax, you sleep well. So I am sure the organizers, you've done an amazing job. Anil, and especially this strong voice of Anita. Where is Anita? Stand up, please. Big round, biggest round of applause. Professor Anita, thank you so much for being on time and putting us on the right guidance. I am also very grateful to the entire ISSMGE board coming here and supporting this event that jumped from being a Geotech Asia to Geotech World for the lifetime medal or award that our poor grand pioneers received. It was really nice thing to do here, and it touched me. Every moment was special, and seeing people coming from all over the world, you know, Brazil, Germany, Chile, Korea, Australia, Japan. It was really amazing. This is the beautiful, what I see here, the geotechnical family. Congratulations, and thank you all for being here.
Thank you, sir. Now I invite the guest of honor of this session, Professor K.G. Anshu, Vice President Asia, ISSMGE, to give the closing remarks.
Yes, I would like to let you know that actually this event was initiated 2 years ago in Astana, Asian Council, during the 17th ARC. I'm so happy that we make it happen in 2 years. Again, I would like to acknowledge and congratulate Indian Society and the organizing committee who make this event so successful. Let's give him a big hand. Good job. And secondly, I would like to let you know that on October the 8th, we have an Asian Council meeting here. We decided to have AYGEC together with Geolandu in 2027. And also we have another big event, 18 ARC will be held in Thailand, Bangkok. And also the second Geotech Asia will be held in Iraq, in Tehran, in 2021. So I hope to see you very soon. Thank you.
Thank you, sir. And now to make remarks on the conference, I invite Dr. Walter Panidua, Vice President, North America of ISSMG.
Hello. Thank you. I have to write this down. I don't want to forget one point. I literally came from the other side of the world. From my country to here, we have 11 and a half hours difference in time. So we're literally on the other side. And I was amazed by the excellent organization and logistics. Many people have talked about that, but I would like to outstand it. From the food, the cultural events, all the presentations, the timeline, etc. Congratulations. Second, the great quality of the presentations. The technical level was outstanding. I would like to make a highlight on that. And third, but perhaps it should be the first, the outstanding Indian hospitality. You were so kind. We were very pleased with your hospitality. Well, all I can say, it is a big success, and well, my sympathies to Tehran. It will be quite a challenge for the second beautification. Thank you.
Thank you, sir. And now I invite Dr. Anil Joseph, the organizing chairperson of Geotech Asia 2025, to officially declare the conference closed and for handing over to the second Geotech Asia 2029.
Good evening all. So it's a great privilege. It was a long journey, and then it's just coming to a close today. Today we were sitting for evaluating the best stall award, and we were focusing on the subject of geotechnical engineering. But then there was one team called Team Sunny Sangla, despite not being from the geotechnical industry, has supported us as the title sponsor. Thank you, Murthy, for bringing them to us together. And let us give a big round of applause for Sunny Sangla Group for the special support they have given to make this. And we all heard how passionate they were to get it moving. As we close here, I would now like to request Mandip Subedi, who is going to do the Asian Young Geotechnical Engineering Conference, and Geo Mandu to come over and say a few words. But now I see Fardeen is here. I was calling from one day, right from the morning I was trying to reach him. But the problem is that he was in Goa and he was celebrating the success of getting the second Geotech Asia, and they are going to host in 2029. So may I call upon Fardeen to announce that, and can we officially hand it over with your slides will be coming up soon. And please, Fardeen, do come in. This was a big major decision which was taken in the Asian Council meeting after a tough round of voting with 3 countries participating. Next Geotech Asia 2029 will be held in Tehran, and I welcome the Iranian Geotechnical Society President Fardeen to do the honors.
Thank you very much, your friends and colleagues, especially my Indian colleagues, which I'm sure that we will have a very tough job, as mentioned in the second one. So anyway, we will do our best. Of course, it will not be possible without your help. I mean, geotechnical engineering family, ISSMG family, I'm how to say, requesting all friends and colleagues all over the world to help us, especially Asian colleagues, and I hope to be able to arrange something like the first one, but we will do our best, but I'm not sure that we will be able to, make it similar to yours. But we will do our best, and everybody is welcome to Tehran. No, okay. I can go ahead. Okay. So yes, there is some. I don't know how much time I have, but just all 2 minutes. Yeah, that's it. Yes. So just let me, how to say, move it on. Of course, some information. Yeah. Yeah, because he told me that to meet. So of course, you know, the Persepolis, Pasargad monument, which there is a lot of geotechnical engineering and earthquake seismic proof in design in this more than, 2000 and something years ago, resting place of Cyrus. In my ground improvement classes, I'm starting with this slide and explaining about the geotechnical improvement that our ancient fathers did, and also seismic design of this monument. Anyway, and of course Isfahan and other places. Regarding our society, it is established in 1971 and become the member of the International in 1974. Just I'm going through the, very fast, sorry. Different conferences we have arranged and different famous colleagues have been participated in, and also we encouraging the young generation, as I mentioned yesterday, to be very active in our society, especially with GeoWalk competitions, which is one of the very interesting ones that we have performed it 8 times, and every year almost we are doing that. Regarding invitation to Tehran, of course, for this second conference, different places as a venue we have discussed and might be decided, and of course a lot of hotels could be selected for our guests, and technical exhibition of course will be available, and some cultural program for seeing the museums and going to Isfahan or Shiraz, our ancient capital Isfahan, for visiting the different art. Reaching to Tehran is not so difficult. We have 2 international airports there, and different airlines are going there, and also getting the visa is also very easy. 2 weeks visa without no stamp now is the easiest way maybe, but it could be longer visa also. It could be given to the visitors. So registration fee, I'm not going through the detail. We will do our best to have cheap conference, low price for registration. And I got my answer now. It was the question, but we didn't have any conference in West Asia, and we got finally this time.
Also, we have the Asian and Geotechnical Engineering Conference coming up in Kathmandu. So Nepal has won without a competition this time. May I call upon Mandi Subedi to brief on GeoMandu 2027 and take a few words to welcome all the gathering for the Asian and Geotechnical Engineering Conference and GeoMandu plan for 2027.
Thank you, Dr. Anil Joseph, for inviting me on the stage. Good evening, ladies and gentlemen. It is a great honor to speak on behalf of Nepal Geotech Society on this wonderful closing ceremony. These 4 days have been truly inspiring and full of learning and friendship building for all of us. I would like to thank Indian Geotechnical Society and the organizing committee for this grand conference, for the warm hospitality and the excellent management during these 4 days. Congratulations to all of you for this great grand success. Congratulations. I salute the dedication and the hard work of this organizing team and Dr. Anil Joseph for this leadership and the society. You have really done an excellent job. We are glad to share that more than 20 participants from Nepal joined this conference. Not just only to learn, but also to demonstrate our brotherhood. As Dr. Mark Balud says, geotechnical without borders, and as Anil Joseph beautifully adds, brothers without borders. In the same spirit, I would like to add friendship without borders, getting knowledge without limits. In this occasion, I am well happy to share that the 11th Young Asian Geotechnical Engineers Conference will be held in Nepal in May 2027. I sincerely thank Professor Shao and Dr. Joseph for encouraging Nepal Geotech Society to apply for this, and thanks from my heart to all the Asian Geotechnical Societies supporting for this. At the end, thank you once again for these unforgettable memories. I look forward to welcome you in upcoming AYGC and Geomandu in Kathmandu in 2027. Thank you so much. And this is the preliminary brochure of Geomandu 2027. Thank you, sir.
Thank you. So I would like to give a special prize to the Sunny Sakla group, who has done wonderfully well and supported us and was so enthusiastic. She was here from the day one, was there in all the activities, and such a big support for this conference. Please come in, Manila sir. Sakla to receive the award.
Just don't leave the stage yet, because what you did is amazing outside your world. People like you make such events successful, so thank you very much. You and all the sponsors, all the exhibitors, without you, there is no conference, really. Thank you.
And now we have a surprise announcement. PAT Mediterranean Conference is going to come in 2026 and Mark is going to host that. Let us all get ready to go to Lebanon for that, and I call upon Mark to announce the same.
So very quickly, since I was elected president, coming from this tiny country, Lebanon, I thought of doing something for my home country. And then, slowly, the idea of building that new regional conference started developing, and it became realistic and done about a year ago by signing a memorandum of understanding. So we have within ISSMGE, we were able to create two regional conferences, the Geotech Asia, which was inaugurated now, and Pan-Mediterranean Geotechnical Engineering Conference, gathering 3 continents around this beautiful sea. And you know, the next Geotech Asia is in 4 years, Geomandu is in 2 years, this one is next year in a few months, and it is inside Asia, so that's why thank you for allowing me to present it. It's going to be a short video inviting all of you to attend and come visit this lovely city of Beirut. And I'm presenting this on behalf of the Lebanese Geotechnical Engineering Society that is led by Professor Grace Abu Jawde. She couldn't be with us, but I'm helping. Thank you. Can we play the video? besides the technical part.
Thank you, President. And now it's a feedback section. For providing a feedback on the conference, I invite Dr. Mandeep Subedi, immediate past President of Nepal Geotechnical Society.
Thank you, ma'am. Actually, I kept the feedback when welcoming to the next Geobantu. It was really great. It helped us to not only to experience the knowledge sharing program, not only to gain to share our experiences, knowledge, and also to gain knowledge, but also it gives us the forum, it gives us the platform to be to know about ISSMG, to know the different cultures and the beautiful city Goa. I am very happy, and I feel this is one of the best conferences in the world. Congratulations, Dr. Anil Ajati. Congratulations.
Thank you, Dr. Mandeep. Now I invite Dr. Amar Pathak, Deputy General Manager from Monte Carlo, to provide a feedback.
Good evening, everyone. It has been a great pleasure for Monte Carlo to be a part of Geotech Asia 25 as a platinum sponsor. It was truly inspiring to see world-renowned thought leaders and geotechnology experts under a single umbrella, sharing their insights and experience. For me personally, it was a memorable opportunity to interact with many of them while introducing Monte Carlo and the work we do. I would like to extend my sincere thanks to Dr. Ashish Juneja, Dr. Anil Joseph, Dr. Murthy for facilitating the participation, and a special thanks to Jigisha for smooth coordination and continuous support throughout the event. This has been a wonderful and memorable experience for all of us at Monte Carlo. Kudos to the entire organizing team, and our best wishes for continued success in future editions of Geotech Asia. Thank you so much.
Thank you, Dr. Pathak. We will take one more feedback, requesting anyone from the audience to provide us a feedback.
Hello, good evening all. Okay. The memory about Geotech Asia is when on the Indian Geotechnical Society WhatsApp group, we received an information that India won the bid. From there, I think Professor Ashish Juneja and we were discussing, and then as a company we had supported it with a planning of 2 years ahead, and that's what it could possibly we could do. And I think it's really wonderful. First Geotech Asia has put a benchmark for the event, and I really thank all the organizers, especially Professor Ashish Juneja, Professor Dasaka Murthy, and Dr. Anil Joseph. I can understand the kind of efforts have been put in, and whenever I used to discuss with Professor Ashish Juneja, always either he is catching flight to Goa or coming back from Goa. So I can understand how busy it was. Thank you all the organizing team. It is wonderful experience. Such a nice, interesting, technical depth 4 days. Thank you very much.
Hello, good evening everybody. Just a small feedback and also a token of appreciation to everybody. Honestly, when we thought of coming to, we were not given a complete idea that Sunny Sankla had sponsored, but we belong to Sanur team, one of his verticals. So I did not have a complete idea of what we are going to do in the Geotechnical Society. But I I should mention this, I have felt so homely and so welcoming from everybody that one thing I realized, even if we are not from the same field, everybody is interconnected. So the amount of inquiries, the amount of inquisitiveness with everybody that I had on the stalls, everybody was surprised equally to see us that we are not from the allied field, but I feel, looking at the curiosity from all of you, we are going to make very good in the future, and we promise to continue supporting to this thing always, because it is amazing, the amazing responses, and I'm sure we are going to go 1-fold to 1,000-fold from here, and we'll always see you. So I've made very good friends. Thank you, Arvind, Joseph sir, thank you, Murthy sir, thank you, Juneja sir, thank you so much, and a special mention to Mark sir for always being so enthused, and always also the event team, everybody has supported us in every way. Thank you for acknowledging our efforts also, and thank you all for being here. Amazing event, everything just was amazing. Thank you so much.
Thank you, Ms. Manali Sankar. And now we move on to the vote of thanks. I request Dr. A.P. Singh, the Honorary Secretary of Indian Geotechnical Society, to please give away the vote of thanks.
Namaskar, good evening to all. It feels just yesterday that we welcomed you to the inaugural morning of the Geotech Asia, the first Geotech Asia 2025, the very first of its kind. And today, as we stand at its conclusion, there is a quiet sense of pride in what we have achieved together, and gratitude for the journey that has brought us here. Over these days, we have witnessed a truly extraordinary confluence of minds, from stalwarts and pioneers, each one leaving behind a trail of knowledge, inspiration and purpose. We have learned about innovation that are redefining our field, from smart sensing and AI-driven design to sustainability, resilience and climate adaptation. The exhibition halls buzzed with innovation. Our panel discussion brought continent together, and our social evenings reminded us that geotechnical engineering is above all a community, a family bound by curiosity and collaboration. Thank you everyone for making this happen. At this moment, it is only a fitting to express our heartfelt appreciation to the people who have made all this possible. Our deep gratitude to the International Society for Soil Mechanics and Geotechnical Engineering, ISSMG, and its dynamic president, Dr. Mark Bose. Thank you, sir. Our sincere thanks and gratitude to BP Asia, ISSMG, Dr. Albert Saab. Thank you, sir. Our sincere thanks to Dr. Walter, BP North America, ISSMG. Special thanks to Engineer S. Cooper for coming to this conference, joining and motivating our youngsters. Really, our students are motivated by your presence, for your vision and encouragement. To the Indian Geotechnical Society and its president, Dr. Anil Joseph, for his leadership, guidance and tireless effort in bringing Geotech Asia to life to make it live. A special words of thanks to our organizing chairpersons, Professor Dasaka Murthy, Professor Ashish Juneja and Dr. Anil Joseph, whose dedication and teamwork have been the driving force behind this landmark event. To our patrons, National Advisory Core Committee, Vice Chairpersons, Organizing Secretaries, Joint Organizing Secretaries, members of Finance Committee, Technical Committee, International Networking Committee, and the entire team from IIT Bombay, IGS Mumbai chapter, and IGS Goa chapter, IGS Kochi chapter, and many more behind this team. They really deserve a big thanks and gratitude for all their effort to make this program very successful. Thank you all for month of planning, countless meetings, and the flawless coordination that has made this conference a grand success. On behalf of the organizing committee, our sincere appreciation to our distinguished speakers, moderators, panelists, sponsors, exhibitors, and partners. Each one of you have added immense value to this gathering. And above all, a big thank to our delegates who traveled from across the world, shared your ideas, and keep the spirit of Geo Buddies alive in every conversation. Thank you very much for this, making this program a grand success. Thank you.
Thank you all. With that, we come to the official close of Geotech Asia 2025. Request everyone to rise up for the national anthem. Thank you all. Ladies and gentlemen, on behalf of the organizing committee of Geotech Asia 2025, thank you for being part of this historic event. We wish you safe travels, continued success, and the very best in all your professional endeavors. And as always, in the spirit of GeoGuidance, let's keep moving forward. Thank you and good evening. And we have a photo session now. With that, myself, Dr. Anita Chipale, sign off, along with my team, Dr. Shitija, Dr. Jijisha, and we have our girls here, Ms. Alina, Ms. Ashita, Ms. Ashwini, and Ms. Adilakshmi. Thank you all.
Did you ask everyone to come for the photo? So, just to be clear, let's take a group photo for the whole family that stayed around the closing. With apologies if it took so much time, but yeah, all come here on stage. We really like to be together in the last picture of this event.
Some applications are
Please come forward so that we will quickly take a photograph and we can leave. Please come forward.
Boys, just move inside, please.
Ready?
Are you guys ready?
Yes.
On geotech, give it up for geotech, guys.
Ani karkada.